Right now, the way we feed documents to AI is broken. When you ask a standard AI agent a question, it scrambles to assemble context from your files, and the moment it answers, that context shatters entirely. It resets to zero. This is Retrieval Augmented Generation, or RAG. It forces the language model to search through raw data, pull out relevant chunks, and synthesize an answer from scratch for every single prompt. There is no memory. Nothing compounds. To solve this, we have to stop treating knowledge retrieval as a just-in-time operation. Instead, we need to shift to ahead-of-time compilation. This approach is often called the LLM Wiki. Instead of searching raw documents at runtime, an asynchronous background agent digests your immutable sources once and compiles them into a persistent, interlinked semantic graph. To actually build this, teams need a shared language. That language is Google's new Open Knowledge Format, or OKF, combined with specific deterministic graph methodologies.
Agentic intelligence requires persistent memory that compounds with every new document. Building that persistent memory requires a specific three-tier architecture, a theoretical model outlined by AI researcher Andrej Karpathy. At the foundation is Layer 1, raw sources. These immutable inputs are never altered. Above that is Layer 2, the wiki body, a central repository of interlinked pages generated entirely by the LLM. The top layer is the schema, dictating the agent's operational rules. By organizing the system this way, human curation is isolated to the bottom layer and top rule set. The LLM autonomously maintains the massive interconnected data layer in the middle. Until recently, everyone building one of these middle wiki layers used their own bespoke formatting. Now, Google Cloud has standardized it with the Open Knowledge Format, version 0.1. An OKF bundle relies entirely on your local file system. There is no proprietary database, no active runtime, and no API keys required. The format is simply a directory of standard Markdown files, each containing a YAML front matter block at the top. The specification is deliberately minimal. Out of all the metadata you can include, that type declaration is the only mandatory field. The format also reserves two specific file names. The first is index.md, acting as a directory listing. This allows an agent to see what is available in a folder before it opens every file inside. The second reserved file name is log.md, a chronological change history providing an audit trail of updates. Because the format is so simple, it cleanly decouples the systems involved. A pipeline-generated export can produce the knowledge, and a completely different AI agent can consume it. Formatting agentic knowledge as raw Markdown eliminates vendor lock-in and creates immediate cross-platform interoperability. To understand why this formatting matters, we compare standard runtime retrieval against OKF compilation. In a standard RAG setup, documents are broken down through semantic chunking, converting the text into vector embeddings. On the left, semantic chunking destroys the author's original structural context, scattering the logic into disconnected blocks. Advanced frameworks solve this by using a two-step chain-of-thought ingest pipeline. In Step 1, the agent performs a comprehensive analysis over the entire raw source. In Step 2, it generates discrete, cross-linked OKF pages, applying incremental SHA-256 caching, so unchanged files are skipped. Two-step ahead-of-time ingestion preserves the logical intent and structural relationships of the original document. Runtime chunking simply discards them. Once those OKF pages are generated, the system relies on a four-signal knowledge graph to retrieve information, replacing traditional vector search. First is the direct link, applying heavy weight to explicit wiki links. Second is source overlap, applied when pages share raw source metadata. Third is topological prediction, inferring relationships between nodes with common neighbors. Fourth is type affinity, connecting pages with the same OKF type declaration. Over top of these four weighted signals, the system applies the Louvain community detection algorithm. This algorithm enables agents to autonomously map distinct knowledge clusters and identify missing conceptual bridges. Explicit deterministic graph signals provide the rigorous pathfinding required for multi-hop reasoning, tasks where traditional semantic vector search often loses context. Translating this mathematical logic into a real-world enterprise environment requires standard DevOps tools.
The producer workflow begins with a CI/CD pipeline running an enrichment agent that pushes OKF updates to a central repository. For the consumer workflow, a local MCP server reads that bundle directly, exposing it to a coding agent inside an engineer's IDE. Start small. Point a script at a single data warehouse schema and have it output a version-controlled OKF bundle. Standardizing on these portable Markdown directories allow organizations to build a human auditable knowledge base that matures alongside their agents.
Okay, your journey definitely doesn't stop here. Let's see what AI on Air has lined up next.
You just crushed this explainer, but honestly, are you ready to actually understand AI's mind? We've got deep dives into the good stuff, from basic LLMs to crazy complex attention mechanisms.
Want a peek inside an AI's brain? You've got to check out our dictionary learning breakdown.
Plus, we've got awesome bilingual content, like literally teaching AI how to see with RAG visual.
We build it all step by step, going from those foundational LLMs right into AI ethics.
Whether you want deep, structured playlists or just quick, bite-sized shorts, we've got you covered.
Binge our AI on Air series or tackle system design. It's perfectly structured to accelerate learning. Short on time? Catch fast updates like Ombre Artificial or our upcoming agentic AI stuff. The best part? There are 11 high-quality explainers sitting right there ready for you now. Come join our exclusive crew of 16 early adopters who are literally mastering AI today. Seriously, why miss out on the very algorithms that are shaping our entire future?
So hit subscribe at AI on Air 77 right now. Let's navigate this automated future together.